If you were to take an optical fibre and cut it down the middle and look at its cross-section under a microscope, you would see essentially a glass plane. If you look very carefully and closely, you would see in the middle of the fibre a region that is a slightly different colour. That's called the core of the fibre, and the core actually includes a slightly different composition of material. It's called doped material, and the core has a higher refractive index than the so-called cladding region that surrounds the core. And the point of this core region is that's where the light is actually trapped and confined in the core based on total internal reflection. So optical fibres guide light through total internal reflection, which is a very old, well-known piece of physics, and basically it relies on the fact that the light, when propagating in a medium of a high refractive index, wants to stay in the high refractive index medium, and the natural tendency for light to diffract will be overcome by this refracting effect as the medium light transfers into the surrounding low index material, and that's known as total internal reflection. So glass is the essential material, but at the same time we need the core for total internal reflection, and it needs to have a refractive index slightly higher than the cladding region, the glass cladding region. So what scientists realized about 30 years ago at Bell Laboratories in the US was they realized they can deposit chemicals in the preform, in the middle of the preform, in the core region, for example germanium, that will raise the refractive index of that central region. The reason you dope the core is because you need the high refractive index to guide the light through total internal reflection.